Welcome to MRL. In this learning session, we'll study the second part of the Introduction to Polynomials chapter, Ganita Manjari 9th Standard CBSE textbook. So now here, let us begin with the univariate polynomial. Now what is this univariate polynomial? A linear polynomial with one variable is called univariate polynomial. Very simple. A linear polynomial with one variable is univariate polynomial. Now let us take an example and understand this. Let us frame a linear polynomial first. We have a square of side x and the perimeter of the square is definitely 4x because the sum of four sides is perimeter. So perimeter of the square is 4x. That means we have a linear polynomial px is equal to 4x and it is a polynomial which gives us the perimeter. Rather, the perimeter is a function of x, which is the side of the square. Now let us take a few examples here considering different values of x. So we have side, if it is 1 centimeter, definitely the perimeter is 4 centimeter because 4 into 1 is 4 centimeter. If it is 1.5 centimeter, the perimeter is 6 centimeter. If the side is 2 centimeter, the perimeter is 8 centimeter. And if the side is 2.5 centimeter, the perimeter is 10 centimeter. Rather, the perimeter is a function of the side or x. Px is a function of x. The perimeter is a function of the side of the square, and that is very clear. Now if you observe this table here, the perimeter increases by 2 centimeters when, please take this as when, not it is n is missing there. So when x increases by 0.5 centimeter, the successive values have a constant difference. If you subtract here, 6 minus 4 is 2, 8 minus 6 is 2, 1 and 10 minus 8 is 2. So the values the successive values have a constant difference, and therefore the values exhibit a linear pattern. The values form a sequence. In fact, 4, 6, 8, 10, which are the perimeters, they form a sequence, and we'll be learning about the sequence in your higher classes, and it is called as arithmetic progression. So a linear polynomial therefore forms a linear pattern of values or forms a sequence, and please remember that. Now coming to the next point, second example rather. Now we have the number of matches played here, 1, 2, 3, 4, 5 and so on. The amount paid for the first match is 250. The fixed charge is 200 and 50 rupees is the additional. Therefore the first match you will be paying 200 plus 50, that is 250. Second match again 50 more, that is 300, and third match again 50 more, 350. Fourth match again 50 more, 400, again 50 more. For the fifth match is 450. So therefore we can frame a polynomial, a linear polynomial for this particular example. Therefore polynomial m, that means I have taken m as a variable here. So Pm is equal to 200 plus 50m is a linear polynomial, and the variable is m. So therefore the polynomial is a function of m. Now if I put m as 1 here, if I put m as 1 here, number of matches, if the number of matches played is 1, then m is 1. So 50 into 1 is 50, 200 plus 50 is 250. If m is 2, 50 into 2 is 100, 100 plus 200 is 300. If m is 3, then it is 150 plus 200, 350. If m is 4, and so on, we can find out all the amount paid for any number of matches, and that is what is the linear polynomial framed here. Now the amount paid increases linearly because the consecutive values, that is the consecutive amounts paid, have a common difference or a constant difference of rupees 50. So therefore therefore we say that the amount paid forms a linear pattern, or we can also say it forms a sequence. So a linear polynomial therefore forms a linear pattern or a sequence. The number of matches and the amount paid establish a linear relationship. This is very important here. Now the amount paid is a function of m, and m is the number of matches played, and therefore we say there is a linear relationship between the number of matches played and the amount, the number of matches played and the amount paid. Please remember that. Now coming to the other important examples of linear pattern. First of all, let us understand the definition of linear pattern first, because since we have taken examples of linear pattern, so let us understand what is the definition of linear pattern. A sequence of numbers where the difference between two consecutive terms is a constant is called a linear pattern. A sequence of numbers, please understand this, a sequence of numbers where the difference between two consecutive terms is a constant is called a linear pattern. So please understand this. Now let us take a few more examples on linear pattern. Let us consider this example. We have stages 1, 2, 3, 4, 5, 6, 7, which is given in your textbook. The number of tiles for first stage is 1, second stage is 3, third stage is 5, fourth stage is 7, fifth is 9, sixth is 11, 7 and 13, and so on. We can go for the n stages. So for n stages we have the general polynomial as 2n minus 1, and let us verify this. If stage is 1, then 2 into 1 is 2 minus 1 is 1. If stage is 2, 2 into 2, 4 minus 1 is 3, and stage is 3, 2 into 3 is 6, 6 minus 1, 6 minus 1 is 5, and therefore for the n stages, if the stage is n, then the number of tiles will be 2n minus 1. So it forms a linear polynomial. Pn is equal to 2n minus 1. The difference between consecutive terms here, if you find 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, and so on, a constant difference of 2 is there, and therefore the values, the number of tiles form a linear pattern. So the number of tiles form a linear pattern, and also there is a linear relationship between the stages and the number of tiles. Please remember that. So there is a relationship between the number of tiles and the number of stages, and that is what you have to understand and remember. Now coming to the second example, we have got days 0, 1, 2, 3 and so on to n. The amount left is rupees 100, on 0 day it is 100. 5 rupees is spent on the first day, therefore the amount left is 5 rupees less 95. Second day 5 rupees again less 90 rupees, again 5 rupees less 85 rupees, and if it is nth day, then it will be 100 minus n into 5, that is 100 minus 5n. So this is a linear polynomial again. Okay, so just put n is equal to 1, 2, 3, 4. If I put 0 here, it becomes 100. If I put 1 here, it becomes 95. If I put n is equal to 2 here, it becomes 90, and so on. So it's a linear polynomial, and the values, if you observe here, they form a linear pattern, and also there is a linear relationship between the amount left and the number of days. Now let us take one more example, again the example which is discussed in the textbook. Now kilometers traveled, 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers and so on. For the first 2 kilometers the amount is 25. That means first 2 kilometers there is no change in the amount, the fare, that is 25 only. But in the third kilometer you have to pay 15 extra. That means 25 plus 1 into 15 is 40. For the fourth kilometer, again 15 rupees extra, that is 25 plus 2 into 15, that is 55. That means you have to pay for the nth kilometer 25 plus 15 into n minus 2, that is 15n minus 5. So we can put the value of kilometers, 1 kilometer, 3 kilometers rather, not first 2 kilometers is fixed, that is 25 rupees for third kilometer. So if I put 3 here, 3 minus 2 is 1 plus 15, it becomes 40. Then 4 minus 2 is 2, 15 to the 30 becomes 55. So this is the linear polynomial. Again here the Pn is a function of distance, rather the fare is a function of the distance traveled. So more the distance traveled, more the fare, and also if you find the consecutive values of fare have a constant difference, and the constant difference as is very clearly visible, that is 15 rupees. Okay, and therefore it is what you call a linear pattern, and also there exists a linear relationship between the fare and the kilometers traveled. Now having understood this, now we have two very important linear patterns, and that is the linear growth and linear decay. So let us understand one by one. If the values of a linear expression increases with the increase in the variable x, then it is a linear growth. That means if there are two values and if there exists a relationship between them, linear relationship between them, then if one value increases, the other value also will increase, and if that is the case, then it is a linear growth. Now let us take one example and understand this. Now if you see here, the distance d is increasing from 0, 1, 2, 3, 4, 5 and so on up to d, and the cost is also increasing from 100 to 160 to 220, 280, 340, 400 and so on. That means there is an increase of 60 rupees here, and therefore the general formula will be 100 plus 60d, and this is a linear polynomial. So therefore the function of the cost, the cost is a function of distance rather. So cost CD is equal to 100 plus 60d. If I put d as 0, I get 100. If I put d as 1, I get 160. If I put d as 2, then I get 220. 3, we get 280. 4, 340, and so on. So cost is a function of distance. The value of c increases as d increases. If it is c0, as I have already told you, the values of cd show a linear growth. There is a linear growth here. Okay, you have seen the cost is continuously increasing, and therefore there is a linear growth. The values of have a constant difference of rupees 60. The values form a linear pattern, and the values are also forming a sequence. So therefore a linear growth, please understand, a linear growth has it forms a sequence. It forms a linear pattern. There is a constant difference between consecutive values of the cost, and therefore, and also when you study the graph, you will understand that the linear growth has a rising straight line graph. We will be learning that later. Okay, now let us go further. Now coming to the linear decay. If the value of linear expression decreases with the increase in value of variable x, then it is a linear decay. Here two values are there, one is a function of the other, but if one increases and the other value decreases, then it is a linear decay. Let us take one example. Now if you see the month, that is the time, increases from 0, 1, 2, 3, 4 and so on, and the height of the water in the tank decreases from 3 to 2.5 to 1.5 and 1. So the time is increasing, the number of months are increasing, and the height of the water is decreasing in the tank, and therefore the height is a function of time, or ht is equal to 3 minus 0.5 t, because every month there is a decrease of 0.5 meters, and therefore when the time is t, the decrease will be 3 minus 0.5 t. So the value t increases, the value h decreases here. One is increasing, the other one is decreasing, and therefore it is a linear decay. So now if you see here the values of h, that is 3, the value of h is from 3 to 2.5 and reaches to 1. That means there is a continuous what you call decrease. The values exhibit a linear pattern, the values form a sequence, and the constant difference between the terms of the height is, that is 0.5 meters, and therefore it is forms a linear polynomial, and h is a function of the time. Remember that. Now coming to the next and very important thing, that is linear relationship. The linear relationship. Now what is that linear relationship? The linear relationship represents the relationship between the two variables x and y. So if there are two variables x and y, one is a function of the other, and therefore there is a linear relationship between them. Where one is a function of the other and is therefore expressed, please understand, a linear relationship between two variables x and y is expressed in the form y is equal to ax plus b. Y is a function of x. Y is equal to ax plus b is a linear expression, or even you can call it as a linear equation. Here a is the slope. Please understand this. A is the slope of the line graph of the linear expression. So when I draw a graph of this equation, I get a straight line graph, and the straight line has a slope, and a represents the slope of the graph of the linear expression y is equal to x plus b. B is a constant here. It is the y-intercept. We'll understand it more clear when we learn about the graphs. The graph of y is equal to ax plus b is a straight line, a is the slope, b is the y-intercept. Now this same equation y is equal to x plus b can also be written as y is equal to mx plus c, which is a very important equation of which is called as the slope-intercept form of equation of a line, which you will be learning later in your higher studies. Now to understand all this, let us take one example, that is example of a linear equation, that is linear expression y is equal to 2x minus 1. If I take y is equal to 2x minus 1, then here y is a function of x, so but for different values of x I get different values of y. If x is 1, 2 into 1 minus 1 is y is 1. If x is 2, 2 into 2 4 minus 1 is 3, and x is 3, 2 into 3 is 6 minus 1 is 5. So that is how the functions of x and y, we get the value of y we get for different values of x. Now if we want, we can draw the graph of that and understand it better. Now the graph of a linear relationship, this is what we have to learn, and we have to also interpret it. Now what is this graph of a linear relationship? Now y is equal to ax plus b is the general form of a linear equation. It expresses a linear relationship between two variables x and y. So y is a function of x, and it also exhibits a linear relationship. Now the graph of a linear equation is a straight line. We already know and we have learnt it that y is equal to ax plus b gives us a straight line, and here a is the slope and b is the y-intercept. So let us take one example. Y is equal to 2x plus 1. Let us draw the graph and see exactly what is the nature of the graph. The graph can be drawn if we can locate 2 points on the graph paper, because you know that to draw a straight line we require at least 2 points, and we have to find the coordinates of those 2 points to locate them on a coordinate on a graph paper and draw the line. And for that we have to find ordered pairs. That means for different values of x we have to find different values of y. We have got x coordinates and the y coordinates. So take the equation here, y is equal to 2x plus 1, put x is equal to 0, then y is equal to 2 into 0 plus 1, that is y is equal to 1, put x is equal to 1, then y is equal to 2 into 1 plus 1, that is y is equal to 3, put x is equal to 3, y is equal to 2 into 3 plus 1, y is equal to 7. So we have got the ordered pairs. With the help of these ordered pairs or these coordinates, x coordinate and the y coordinate, we can draw a graph. And this is the graph which is already given in your book. And what is this graph? This is a graph of the equation y is equal to 2x plus 1, and the graph is a straight line graph. The graph is a straight line graph, and its slope is 2, and to find the slope it is very easy. Slope is nothing but it is a ratio of y2 minus y1 and divided by x2 minus x1, y2 minus y1 divided by x2 minus x1. So 7 minus 1 is 6, 3 minus 0 is 3, 6 by 3 is 2, so the slope is 2. Please remember, the slope can be found out by taking the difference of the y coordinates and dividing it by the difference of x coordinates of any 2 points, and we have got the 2 here. So 2 is the slope, and the slope indicates the inclination of this line. The slope indicates the inclination of the line. Inclination means what the angle it makes with respect to x-axis. So therefore we have the slope here 2, and that is the inclination of this line, and that is the slope of this line. And also 1 is the y-intercept. If you observe here, the graph, the straight line graph cuts the y-axis at 1. That means the distance OA is 1. Therefore we say the y-intercept is 1. So the graph cuts at 1, it means its y-intercept is 1. So from the equation we now know that y is a function of x, and the slope is 2, and the y-intercept is 1, and that is what is the graph of the given linear equation y is equal to 2x plus 1. So please remember that. Now further, I have just explained here whatever I have just told you. Now the graph is a straight line that we have seen. The values of x and y satisfy the equation are points on the line. Now what does this mean? That means we have an equation, the values of x and y which satisfy the equation are the points on this line, or any point on this line which can satisfy the equation are the coordinates of that point. So every point and its coordinates satisfy the equation. This is very important. The values of x and y that satisfy the equation are points on the line, and every point on the line which have the coordinates of which can satisfy the equation are the points on the line. So please remember that. That means on the line, any point on the line can satisfy the equation, or the values of x and y which satisfy the equation are the points on the line. Both the things are correct. Now in y is equal to 2x plus 1, 2 is the slope as I have already told you, and plus 1 is the y-intercept. Slope is the inclination of the line to x-axis, again which I have told you. Now the slope is equal to, as I have told you, it is the difference of the y coordinates and the x coordinates. They are taking the ratio of that, we get 7 minus 1 divided by 3 minus 0, that is 6 by 3 is equal to 2. That is the slope which you have to remember. Now y-intercept is plus 1, which I have already shown. The graph cuts the y-axis at y is equal to plus 1. Slope 2 is positive. This is very important. Now if the slope is positive, because 2 is greater than 0, and the inclination of the graph is towards the right side. So this is a very simple graph drawn, but so much of information is involved in it. So try to remember. And that was the second part of our discussion on this particular topic of linear polynomials. In the next part we'll study further as to what is a linear relationship and other aspects of the topic. So learn these learn these points, whatever I have discussed, note down in the book and revise. Okay, thank you.